we're now going to talk about how we can determine how many different distinguishable permutations there are. So suppose that you were to stand in line with identical twins. Although the three of you can distinguish yourself as a permutation of 3 factorial, or 3 times 2, which is 6. There are 6 different ways that you can stand. Someone who doesn't know how to distinguish between the twins can't tell which one's where, and so they look like they're in the same position. So another way to think about this is to suppose that we had the following setup. So here's some tiles. So the tiles are distinguished as 1, 2, 3, 1, 3, 1, 2, 3, and 1 on one side has a 1, and on the other side has an M. The 2 has an O, and the 3 has an M. So if we were to look at this side, it's very easy to see we've got 6 choices. But if I were to look at this side, notice that when all I do is look at this side, I see an M first and an M last. Well, this guy is the same as this guy, so I can't tell the difference. It looks like I only have 3 permutations because I can't tell if this is the 1 or the 3, if this is the 1 or the 3, or the 1 or the 3. All of these, I can't tell them apart. So this is what we mean when we talk about distinguishable permutations. And so here's the formula. Suppose that we have n total objects, and that n1 all looks similar, can't tell them apart, n2 looks similar, can't tell them apart, dot 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 all the way down to nk, so that we could have k different types. Well, our permutation is equal to n factorial divided by the number in the first set times the number in the second set, all the way times the number in the k set. But here's the key. n1 plus n2 plus all the way to nk has to equal n. So each individual number here has to add up to n when you put them all together. And so let's suppose that we have 9 gifts being distributed between three children. And we want to know how these can be distributed if each child gets 3 gifts. Now remember, order is important. So we actually have 9 gifts. 1, 2, 3, 4, 5, 6, 7, 8, 9. But in reality, we might go, if we label the children A, B, and C, we might go B, A, C, A, B, C, C, B. And so here are my second child, my first child, and my third child breakdown. And all I see is this, that these are the way the gifts distinguish, but I don't know how they are here. Well, in this case, since these are distinguishable based on the first line, there's 9 total. The count of the A's is 3. The count of the B's is 3. The count of the C's is 3. And so we have, notice that 3 plus 3 plus 3 is 9, and this works. So we get 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 times 2 times 3 times 2 times 3 factorial. The 3 and the 2 is a 6. The 3 goes into the 9 3 times, and the 2 goes into the 4 twice. And we end up with 3 times 8 times 7 times 5 times 2. There are 1,680 different ways of partitioning these gifts through the 3 children so that each child gets 3 gifts total.